The fatty acid profile of palm, soybean, and coconut oil blend was analyzed. Fatty acids vary in structure, affecting health factors like cardiovascular function and vitamin absorption. Since oil composition depends on the source, CG with the method AOCSCE was used. 25 cis-trans isomers. Fatty acids were converted to FAMEs for detection. The goal was to verify if Mazola with coconut matches its label and assets its nutritional value against pure oils. To understand gas chromatography basics, including instruments, components, software used, and its role in fatty acid profiling using an Agilent 6890 CG with FID and autosampler. To analyze the chromatograph of Mazola with coconut oil, identify its fatty acid profile, and estimate each oil contribution to assess the product's nutritional quality.
Group 3 Mazola with coconut oil procedure. In phase 1, we started with oil already in liquid form. We added 12 drops to a test tube, then 2 milliliters of isooctane and 0.5 milliliters of KOH. This was done in duplicate. The tubes were sealed, shaken for 8 minutes on a Vertex mixer at a speed 6.5 and left to rest for 10 minutes. In phase 2, we pipetted 1 milliliter of the upper layer containing isooctane and fatty acids into a new test tube. Then we added 4 milliliters more of isooctane and 1 gram of sodium sulfate. The tubes were sealed again, shaken for 8 minutes at a speed of 10 and left to rest. Finally, 1 milliliter of the isooctane phase was pipetted into vials, which were taken to the Agilent 6890 gas chromatograph with FID detector and autosampler.
The results were that 23 peaks were found in the gas chromatography, of which 21 fatty acids were identified. These acids were grouped into saturated, monounsaturated, and polyunsaturated fatty acids, of which there were 8 saturated fatty acids representing 12.84% of the total area, 9 monounsaturated acids representing 86.33% of the total area, and finally 4 polyunsaturated acids representing 0.63% of the total. This percentage gave a total sum of 99.80%. The missing 0.20% were from the 2 peaks that could not be found in the reference fatty acid table. Since their times of appearance did not coincide with any acid in the reference table, these peaks were called noises.
In the chromatographic analysis of Mazola with coconut oil, the fat composition was compared with the product's nutritional data. According to the label, coconut oil should have a high proportion of saturated fatty acids, primarily lauric and myristic, which typically exceed 90% of the total in pure oil. However, our results show an expected predominance of monounsaturated fatty acids at 172.66%, followed by saturated at only 25.68%, which is inconsistent with the scientific literature. When analyzing individual fatty acids, the value for lauric and myristic are much lower than expected, with 2.51 and 1.5%, respectively, compared to the 49 and 18% reported in previous studies. This discrepancy could indicate a low actual proportion of coconut oil in the mixture or possible limitation in chromatographic identification.
In this lab, we can conclude 2 things. First, we learned how to prepare and process oil samples using gas chromatography. We applied a standard method to transform fatty acids into methyl esters and analyze them with the Agilent GC FIT system. This allowed us to identify each compound based on its retention time and evaluate the sample's composition with precision. Our second conclusion is that the fatty acid profile of the Mazola oil blend did not reflect what would be expected from coconut oil. It showed that the amount of coconut oil is far lower than the usual amount found in this kind of products. Some results suggested labeling inconsistencies or possible errors in compound identification, which may affect how healthy the product really is. This raises concerns about the product's true nutritional quality.